Hey everyone, today we're looking at note 7.5, exponential and logarithm conversions. So a logarithm is the inverse of the exponential function. We looked at this when we looked at graphing both exponential and logarithmic functions. In other words, a log is another way to write an exponent. Okay, the standard form for logarithms is read y equals log base b of x, where b is the base, y is the exponent, and x equals what your exponential expression is set equal to. And we're going to look at that here in just a minute. So remember that common log is when the log has a base of 10. In other words, if it does not have a base written, we assume the base is 10. So here's our conversion formula to go back and forth between a log equation and an exponential equation. So, and I use what's called the heart method. You might hear other teachers using a swirl method or the Nike swish. There's all different types of methods, but what I'm going to show you today is called the heart method. So what I mean by the heart method is you start here at this base B, you come around to the Y, you hit the equals, and then you hit the X, and that kind of makes like a heart shape. So what this heart tells me is the order in which, not the size, unfortunately, but the order at which I will write these things when I write my exponential equation. So notice, for the exponential equation, when I convert from a log to an exponential, okay, that I will start with B, and then notice I hit the Y, so Y is what's next. Then I hit the equals, then I hit the X. So like I said, this just tells you the order in which you write, but you have to know that the B, the base here on the log is small, but when you write the base B on the exponential equation, it's larger. Okay, it's regular size. Unlike here, it's a subscript, so it's small. So you would write B to the Y power. So I know here Y is regular size, but here Y will be small. It's a superscript. Okay, and then equals is always just regular. And then X stays the same size. Okay, and you can also do the heart method on this side to go back to this. So you would do B, hit the X, then equals the Y. So again, of course, when you're changing from exponential to log, the first thing you're going to write is the word log. Okay, but then after the word log, you write the B, then the X, then the equals, then the Y. So this just tells you the order to write. Okay, and this is a restriction that you have to have where B is greater than 0, but B is not equal to 1. So let's practice using that heart method. So write the following logs in exponential form. So I'm going to use the heart method to show me the order. So of course this is read log base 6 of 216 equals 3. So when I started my heart, 6 was where I started, so I'm going to write 6. Then I run into 3, so 6 to the third, and then I hit my equals, and then I hit 216. And of course, like I said, you have to know the size. 6 to the third, so it's a regular size, a superscript, equals, and then regular size. And then is this true? Yes, this is a true statement. That's the nice thing about going from log to exponential form is that you can check yourself to make sure that it's correct. And it is. 6 to the third does equal 216. Okay, let's practice again. So doing my heart method. Okay, so I start with 27, so 27 raised to the 1/3, that's tiny. Then I hit the equals, then 3. And that is because, remember, 1/3 power means cube root. So cube root of 27 is 3. Okay, so then I'm going to do this guy. So 5 to the -2 equals 1/25. And y'all should know this is correct because remember that negative exponent means I would bring the 5 to the bottom of the fraction. So it would be 1/5 squared, and 5 squared is 25. So 1/25. Okay, and so this is why we refreshed about common log, because notice we don't have a base here. So if no base is written, 10 is implied. So if you need to write it, write a little bitty 10 there. So 10. You always start at the base. Even if it's not written, you still have to start there. So 10 to the second equals 100, and that is true. That is a true statement. Now, unfortunately, when we're doing part 2, when we're writing in log form, there's not a way to check it unless you use your calculator, which this lesson is a no calculator lesson. So you just need to really make sure that you're doing it right, okay? Again, it's following the heart method, so we always start here with this leftmost value, just like you started with the leftmost value here. So we start with the leftmost value, come around, and make the heart, okay? So this is going to be, remember, when you're going to log form, of course, the first thing you're going to do is write the word log. So log, and then the base of the exponent becomes the base of the log, so it's tiny, log base 3. Make sure it's a little lower, it is a subscript. Log base 3 of 81 equals 4. And you could plug this in the calculator if the calculator were allowed. There is a button on your calculator. I believe it's alpha, what is it? No, it's alpha window. Alpha window and then number 5. Alpha window 5. And that would let you type in 381 and make sure it's 4. And it is, so you're correct. So again, if a calculator were allowed, you would be able to check yourself on these. Okay, let's keep going. So log base 8 of 1 equals 0. On this one, here we go, log base 10, so not necessary to write, of 1 over 100 equals -2. Now I could write the 10 if I wanted to. It gets kind of squished, so I don't really want to. Okay, and then last but not least, log base 4, 4 is where I start, of 64 equals 3. All right, we're done with that. Okay, so now in part 3, we're going to evaluate the following logs. So that means like find out what the answer is. So remember, I would, if I was able to use the calculator, I would just be able to type in log base 8 of 32. But again, like I said, this is a no calculator unit. So without the calculator, since we don't know what this equals, we are going to write equals x because we don't know what it equals, okay? And so knowing that it equals x, a variable, something that we don't know, we are going to convert with something that we are more familiar with working with, and that is an exponent, okay? We're not really familiar with working with logs without a calculator, so we're going to convert to exponential form. So when I do that, I have 8 to the x equals 32. And then what you want to do is you want to get these bases down to as low of a base as you can. Okay, and what I mean is I know that 8 is 2 to the 3rd. So I'm going to sub in 2 to the 3rd power for 8. So 2 to the 3rd power raised to the x equals, and then I also know that 32 is 2 to the 5th. It's 2 times 2 times 2 times 2 times 2. So 2 to the 5th. And how that helps me is because now these sides have the same base. Before, these bases didn't match. I had base 8 here and base 32 here. That doesn't help. Okay, that doesn't help me have equivalent sides. So here you're going to use the knowledge that when you have a power to a power, you multiply. So this is 2 raised to the 3 times x is 3x. And that equals 2 to the 5th. And now what I don't want you to be confused about is I'm not dividing by 2 here. That's not allowed. Okay, it's not going to make sense. What I am doing is saying that since my bases are equivalent now, the only way that these sides, these expressions on either side could be equivalent is if the exponents equal each other. So then I just go straight down into saying 3x equals 5. So the 2's aren't canceling. I don't want you to think I'm dividing by 2 or canceling by 2. It's just common sense that if the bases match, then the exponents must match. So 3x equals 5. So divide by 3, divide by 3. X equals 5/3. Okay, so if I were to plug this in the calculator, I would get the answer of 5/3. All right, let's try another. So equals x. I'm just going to go ahead and write equals x on all of these since I don't know what they equal. And then I'm going to do my heart method since I've already got my red pen. No base written, so 10's implied. Okay, so on this one, 2 to the x equals 16. I'm already base 2 here, can't get any lower than that. So on this side, though, I know 16 is 2 to the 4th. So then once my bases are equivalent, my exponents need to be set equal to each other. So x equals 4. That was an easy one, right? Okay, let's try this one. So 4 to the x equals 2. 4 can be rewritten as 2 squared raised to the x equals 2. So essentially 2 to the 2x equals 2 to the, what's the implied exponent? 1. So then here, if our bases match, we set, if our bases are equivalent, our exponents should be equivalent. So 2x equals 1. Divide by 2, x equals a half. So getting the hang of it, I hope. All right, last one on here, and then I actually do have some things on the back. So no base is written, 10 is implied. So 10 raised to the x equals 1 over 1,000. So it does get a little trickier. Okay, base 10 is as low as I can go on this side. So 10 to the x equals, here's what we're going to do first. We're going to say 1 over 10 to the 3rd, because how many zeros you have with the 10s, that tells you what power you're at. So like 10 with 1 0 is 10 to the 1st, because that's 1 0. So 1,000, since there's 1, 2, 3 zeros, would be 10 to the 3rd. So we're going to rewrite this as 1 over 10 to the 3rd. And then to bring this 10 to the 3rd that's in the denominator up to the numerator, of course, when I go from denominator to numerator, my sign on my exponent is going to change. So that's going to become a -3. And then when my bases are equivalent, then I set my exponents equivalent. And on that one, there's no solving necessary, so I'm done. All right, so let's flip to the back and practice a couple more. So what I have on the back is more practice of part 1, more practice of part 2, and more practice of part 3. Alrighty, so practice from part 1. So part 1 was when we went from log to exponent. So let's practice that real quick, and I'm going to show you why. So we're going from log to exponent. So again, heart method. So 8 to the 0 equals 1, and that is correct. Anything to the 0 power equals 1. So we're good here. Okay, I wanted to practice a regular one because now look at this. So this is set up differently. It's the sides are switched, okay? So you have two choices. You could either think of doing the heart backwards, which to me is kind of confusing, to be honest with you. It really is, because then you're going to have to jump here. You really have to know it. And to me, it's like, I don't know. I would just rather you instead rewrite it log base 4 of 16 equals 2. Write it with what you're comfortable and familiar with. So then it's just regular. So 4 squared equals 16. And that is true. Okay, so of course you can imagine we're going to do something similar here. So this is your regular one from part 2 in the front. Go to log form. So when we're in exponential form and you're asked to go to log form, this is how it looks. So start with log. The base of the exponent becomes the base of the log, so it's tiny on the log. Log base 2 of 64 equals 6. Okay, but again, if you have something written backwards, I highly recommend switching it and rewriting it as 11 squared equals 121, not 121 equals 11 squared. Okay, and then you can go ahead and log base 11 of 121 equals 2. Okay, and now just because students typically want more practice with these because they are funky, I can go ahead and provide you a couple of more. I'll go through them pretty quick, but at least you'll have them on your paper, your notes. That way, you know, in case you need extra help, extra practice. That was a funky looking heart. All right, that one ended up funny. Okay, so here I've got 16 to the x. This is part 3 again. We're doing back to evaluate. Okay, 16 to the x equals 8. 16 can be rewritten as 2 to the 4th raised to the x. 8 can be rewritten as 2 to the 3rd. So this would really be 2 to the 4x equals 2 to the 3rd. And again, when my bases are equivalent, set your exponents equivalent. So 4x equals 3. Divide by 4, x equals 3/4 or 0.75. Okay, now let's get to a harder one. So 1/4 raised to the x. You really need the parentheses because otherwise, if you don't put the parentheses, the x power might be assumed to just go to the 1 and not the 4. Okay, so it would be improper to not write the parentheses. So 1/4 raised to the x equals 32. So similar to what we did on the front, we're going to first bring these down to the lowest base possible. So this would be 1/2 squared raised to the x, right? Because 4 is 2 squared. And then like I showed you before, 32 is 2 to the 5th. To bring this guy up to the top, that's going to become a -2. Okay, so this is going to become 2 to the -2. Raised to the x, so that's going to be 2 to the -2x equals 2 to the 5th. So bases are equivalent, set exponents equivalent, divide by -2, you get x equals -5/2. Alrighty, so this one, 3 to the x equals -9. Okay, right here you can stop. Because this base of 3, there's no way to get these equivalent. This is a 3 to the x. Oops, I put 3rd. I meant squared. And then here's where you have to be really careful because this isn't -3 squared in parentheses because -3 squared in parentheses would be +9, and that doesn't get back to that. This is like a negative and then 3 squared. So remember with properties of exponents, you would do the 3 squared first, which would be 9, and then that 9 would become negative. But these bases aren't equivalent. This is a +3, this is a -3. It's not possible for those two things to ever be equivalent. So the answer is no solution, and not only from looking at that, I hope that you see that, but I also want you to know it because think about your knowledge of log graphs. Okay, you know that a log graph, if it hasn't been transformed, it has that asymptote at x equals 0. We can't have an x value, okay, because remember, this is really where the input is that's negative. We can't have this situation. You can't plug in a negative value into a log. Okay, you can't take the log of a negative number. And we will talk more about it, but hopefully because of the asymptote, you should know that. All right, last one. So 9 to the x equals 1/27. So 9 is 3 squared. And then this is 1/3 cubed. So this is 3 to the 2x equals 3 to the -3 when you move up. So 2x equals -3. So divide by 2, x equals -3/2. Hopefully you've had more than enough practice with this. See you soon.